Welcome to this A320 Type Rating video, presented to you by the AutoPilots. In today's lesson, we will be looking at cabin pressurization, and more specifically, looking at a cabin pressure controller failure. This video is broken down into two parts, a theory and a practical, which covers the total management of the failure. To skip straight to the practical, skip to this time in the video. We hope you enjoy. Welcome to this theory part on the cabin pressurization. In today's lesson, we will look at the cabin pressure system, automatic control versus manual control, the schematics of the pressure system, the cabin pressure page on the ECAM. Then we will explore a Cpc 1+2 failure and look at the management of the failure. Let's dive in. The role of the cabin pressurization system is to manage the cabin pressure on the ground and at all stages of flight. The system consists of two cabin pressure controllers, CPCs, a residual pressure control unit, one outflow valve, one control panel, and two safety valves. The air pressure is primarily controlled by the CPCs. The system receives signals from the FMGS and other systems. Manual operation involves controlling the position of the outflow valve to set the appropriate cabin altitude. The schematics of the pressurization system give us a fairly good breakdown of how the system works. There are various inputs into both the CPCs, including information from the ADIRs, FMGC and LGCIUs. This information is sent to the CPCs, which then move the motors of the outflow valve. This will set the altitude. There are also safety valves which prevent cabin pressure getting too high above 8.6 psi or too low below 1 psi. The cabin pressure page on the ECAM, labeled Press, shows the operation of the cabin pressure system as a whole, and then also three important figures: the differential pressure, delta P, the cabin VS, and the cabin altitude. These figures are also shown on the cruise page in normal flight. Now let's look at a Cpc 1+2 failure. A Cpc 1+2 failure results in the pilots having to control the pressure system manually. Following this, the main goal of this failure is to control the cabin altitude using the outflow valve position. This failure requires good knowledge and monitoring from the pilots. Mismanagement of this failure can result in excess cabin altitude, an exceedance of delta pressure, cabin vertical speed too high. Initially, you will have to take manual control of the cabin pressure system. Then, you are taken to the status page, where you can see target altitudes for a given flight level. This is also available in the FCOM. Now let's look at the MAN VS control switch. The truth is, this switch can be a real hassle. There is a lot of lag when moving it, so if you don't see movement right away, wait at least 10 more seconds before moving it again. A good rule of thumb: one blip is equal to 150 feet per minute. Moving the switch up will open the outflow valve, causing the cabin altitude to increase. Moving it down will close the outflow valve, causing the cabin altitude to decrease. As you descend, the input required will become more frequent. The ECAM is actually quite vague when it comes to how to manage this failure. All it presents us with is target cab outs for a given flight level. The way we are going to fly this involves maintaining the cabin altitude at its target cruise altitude for the descent, keeping cabin VS at 0 the whole way until the cabin altitude is reached, then the valve is fully opened. From then on, the aircraft altitude and vertical speed will be the same as the cabin altitude and cabin VS. This is a safe and effective way of managing the workload. As you can see, there is more than one way of handling this failure. You can keep cabin VS at 300 feet per minute, and then on final approach, fully open the outflow valve. Another way you can fly this is, as we explained in the last slide, keeping VS at 0 the whole way down until reaching cabin altitude. Then fully open the valve. From then, you don't have to touch the cabin VS control switch. Whilst there are different ways to handle this failure, and you're also busy with aviate, navigate, communicate, the key points of managing this failure: to keep the cabin altitude between destination altitude and 8,000 feet. Keep differential pressure between 0 and 8.1 psi, and then it should be 0 when the outflow valve is fully open. And ensure cabin VS does not exceed 2,000 feet per minute.
We have an ECAM alert.
That's checked. Automatics are engaged. We have flight guidance. Weather and traffic are fine. No need to communicate with ATC or crew. Read ECAM.
Cabin pressure system 1 fault. This is confirmed on the SD page, nothing on the overhead panel.
My radios, ECAM actions.
No ECAM actions. Clear cabin pressure.
Clear.
Status.
Stop ECAM. No resets, no expanded checklists. Continue ECAM.
Inoperative systems. Cabin pressure 1. Remove status.
Clear.
Status removed. ECAM actions complete.
Your radios.
My radios.
Thrust idle, DES, 320 blue.
Master caution.
Aircraft is flying fine with the automatics. We are descending in nav. No weather, traffic or terrain about. No communication needed. I am going to level off at flight level 350. Then we can start the ECAM. Mac, out star.
Checked.
Out.
Checked.
Read ECAM.
Cabin pressure, System 1 and 2 fault. This is confirmed on the SD page, with System 1 and 2 in amber. On the overhead, we can see the mode selector push button is in amber. Mode selector, manual. Man VS control, as required. Clear cabin pressure.
Clear.
Status.
Stop ECAM. No resets, no expanded checklists. Continue ECAM.
Status reads, manual cabin pressure control. Target VS, climb, 500 feet per minute. Descent, 300 feet per minute. We have a list of cabin target altitudes based on our flight levels. We are at 350, so our cabin altitude should be 7,000 feet. During final approach, man VS control, full up. INOP systems. Cabin pressure 1 and 2. Remove status.
Remove status.
Status removed. ECAM actions complete.
Okay, Let's talk about how we are going to manage this, and then perform a DODA. I suggest that we keep cabin VS at 0 during the descent, until we reach our cabin altitude of 7,000 feet. Then we can fully open the outflow valve. After that, we don't need to touch it and can focus on the approach. How does that sound to you?
Yes, I am happy with that plan.
Great. In that case, let's begin a DODA. D. We diagnosed the issue of a Cpc 1 and 2 failure. This has left us having to control the pressurization manually, so increased workload. O. Options. Continue, divert or return. We have Paris ahead of us, and will be able to get a shortcut if needed, although there isn't any urgency. We have Dijon right behind us, and some other smaller airports in the vicinity. D. Decide. What do you think?
Paris Charles de Gaulle stands out to me as an obvious choice. We do not have a land ASAP memo, so there is no urgency. It is also our destination, with maintenance. If we divert to Dijon, then we are increasing our workload unnecessarily.
I agree, so let's continue to Paris. Assign. You will be busy with the radios and also managing the cabin vertical speed. I will set up the MCDU and brief you. We do not need to do a performance calculation, or inform the passengers or crew. Then we can have a review later.
I am happy with this plan.
Thrust idle, open DES, flight level 280 blue.
Checked.
Thrust idle, open DES, heading 190 blue.
Checked.
Speed, Des.
Checked.
So for the briefing, there is no change to the plan, except that we must remember to open the valve fully at 7,000 feet. Also, we need to make sure that we have a differential pressure of 0 before we open the doors.
I agree.
Prepare the cabin for landing. (150) blue.
Checked.
Flight level 80 blue.
Checked.
Flight level 70 blue.
Checked.
VS 1300.
Checked.
Heading.
Checked. 1,000 to go.
Check. Out star.
Checked. Okay, I will now fully open the outflow valve.
Understood. Out.
Checked.
E-cam as expected. Thrust idle, open descent, 4,000 feet blue.
Checked.
Approach checklist.
Approach checklist. Baro ref.
1018 set.
Seat belts.
On.
Minimum.
580.
Auto brake.
Low.
EFB.
Stowed, connected. Speed managed.
Checked.
Flaps 1.
Speed checked. Flaps 1. $1,000 to go.
Check. GS, lock blue, Cat 3 dual, AP 1 and 2.
Checked.
Lock star.
Checked.
Lock.
Checked.
Flaps 2.
Speed checked. Flaps 2.
Speed 160 knots selected. GS star, missed approach altitude set to 4,000 feet.
Checked.
GS.
Checked.
$2,500.
Radio altimeter alive.
Check. Gear down.
Speed checked. Gear down.
Speed is managed.
Checked.
Flaps 3.
Speed checked. Flaps 3.
Flap full.
Speed checked. Flap full.
Landing checklist.
Cabin.
Secured for landing.
Go around altitude.
4,000 feet set.
ECAM memo.
Landing no blue.
Landing checklist complete.
One
1,000 feet.
Check.
$500.
Stable.
Check. Autopilot off.
$100 above. Minimum.
Flight slope. Flight slope. Flight
50,
slope.
40, 30, 20. Retard. 5.
Spoilers. Reverse green. Decel. $70 knots.
Manual braking.